Hello guys, I am at CSIR-National Chemical Laboratory Pune, and with me we have Dr. Pranjal Gogoi. Dr. Pranjal has worked extensively on aqueous phase reforming, through which we can develop green hydrogen fuel. Now I request Dr. Pranjal Gogoi to share his experience and knowledge with the viewer on the topic aqueous phase reforming. Over to you, sir.
Thank you, Dr. Atul. So, as we all know that hydrogen productions at this moment, basically we are focusing on fossil fuel-based feedstock. Generally, steam reforming, dry reforming, autothermal reforming, these are the reforming technique we used for production of hydrogen. But the problem with this process is that we perform these reactions at very high temperatures, so it's 800 to 900 degrees centigrade.
That's right.
Along with this, these processes are basically based on fossil fuel-based feedstock. So it releases huge amount of footprint to the environment. Along with this process is not at all carbon neutral process. That is why people are now looking for the production of hydrogens in a, I would say, is more sustainable way. Biomass is one of the alternative process from which you can produce hydrogen in a more carbon neutral fashions.
That's right.
And out of these, your aqueous phase reforming has come into pictures in late 2002. It was proposed by Domeshik and his co-workers. The advantage of this process is that you can perform these reactions at very relatively low temperature. Conventionally, as I mentioned, it is performed at 700 to 800 degrees centigrade. You can perform these reactions exactly 1/3 of this reforming time, conventional reforming. And this represents a huge energy savings during the reforming process. Apart from these, at this temperature zone, I would say like this APR reaction generally perform at 200 to 300 degrees centigrade. At this temperature zone, you will have efficient water gas reactions also. So whatever the bio-based feedstock you are taking for production of hydrogen, in that you will produce, not only produce hydrogen, along with that you will produce carbon monoxide, carbon dioxide, methane, that kind of other reformant also you are producing. But the beauty of this process is that because of the efficient water gas reactions, your CO in the reformant composition will be very much low. I would say it is in the ppm level. So that is why you can directly use this fuel, hydrogen. I would say it is a CO-free hydrogen. You can directly use for fuel cell application.
So what you will say that can we use all kind of bioaccelerated product as a feedstock to generate the hydrogen via APR process? Is it possible?
Yeah. Unless most of the bio-based oxygenated hydrocarbon, you can use that. But the problem with this process is that if you go higher hydrocarbons like C1 to C4, C5, C10 or something like that, so what happens at this moment, your complexity of the reaction will be more.
Yeah, that's true.
And along with that, your selectivity towards hydrogen will be dropped down. Apart from the hydrogen productions, you will have various side parallel reactions during the reactions.
Can we explain to our viewer that what kind of material characteristics the catalyst should possess so as to work in the APR reaction?
Okay, well, so for that actually there are various literature survey also I have done. Along with that, this process, I would say this process still in the lab scale only. So we do not have any commercial catalysts as of now. But what the literature says is that generally the catalyst with basic property is found to be prominent for APR reactions. But along with that, sometimes the catalyst with like moderate acidity also helpful to get very good hydrogen selectivity. But apart from this, when we design a catalyst, we should always take care of like while loading some metal on a catalyst support, like it should be like the catalyst should be since we perform this reaction in aqueous medium, so the catalyst should be like water tolerance.
Yeah.
Actually, what happened, as I mentioned, this reaction is performed in aqueous medium. So water is very good oxidizing agent, and very often it oxidizes the active metal particle to various oxidation states.
But here, Dr. Pranjal, can we develop metal free catalyst. So it should work for that process. Is it possible in the
Yeah,
future?
it is possible.
Yeah.
Metal-free
So
catalysis is possible.
what kinds of parameters we should scrutinize for this?
I already mentioned like this generally basic catalyst is found to be active for reduction of hydrogen through APR process. So I have designed one catalyst like nitrogen to carbon. The beauty of that catalyst is that generally in that catalyst on the carbon support we are loading nitrogen on that. So in that nitrogen not only acting as an anchoring site for the metal nanoparticles, but also it imparts some basicity to the catalyst.
Okay, so somehow nitrogen is playing a role in catalytic activity.
Right.
So now guys, please see the aqueous phase reforming is one of the future methodology to generate the green hydrogen gas. So with this, I thank you Dr. Pranjal Gogoi for sharing this valuable time with our viewers.
Thank you.
Thank you very much. Thank you guys. Bye.